Hello YouTube. What are we doing today? Linear programming. So here's a quick summary from what we did in class. Here's one question we did in class. The homework is page 800 multiple to 10. And let's take a look at number 49. Alright, 49 says, maximize the objective function z equals 5x plus 2y. What happened there? Whoa. Why is that acting weird? What happened there? Okay, good. I should do it. Okay. So, z equals 5x plus 2y is your objective function. Let's say z is how many millions of dollars you make this month in your factory, producing x thousands of cogs and y thousands of widgets, say, okay? Now here are your constraints. X plus y is less than or equal to 10. 2x plus y is greater than or equal to 10. And x plus 2y is greater than or equal to 10. And you always have this. X is greater than or equal to 0, and y is greater than or equal to 0 because x and y cannot be negative, okay? What does that mean? Well, think about it. Y equals 0 is a horizontal line, the x-axis. And if you shade greater than y equals 0, you're shading above the x-axis. Okay. X equals 0 is the y-axis, the vertical line. And if you're shading for x is greater than 0, you're shading to the right of the y-axis. So these two constraints just mean you're only graphing in the first quadrant. Okay, so let's just focus on these constraints. How do you graph these inequalities? Well, what I do is I pretend they all say equal to first to draw the lines. So let's do that. So here's your y-axis, here's your x-axis. All right, so what if you, let's just do the intercepts. If x is 0, y is 10. This point, 0, 10. If y is 0, in the first, I'm doing this first one here. If y is 0, x is 10. This point here, okay. Connect the dots, and you have a line. A line is defined by 2 points, right? So there you go, any 2 points on the line. And let's label that so we know which is which. X plus y is 10. Okay. All right, let's do this one. 2x plus y equals 10. So let's say that x is 0. What's y? It's also 10. Okay. But what's y? If y is 0, 2x equals 10, x equals 5. So it goes through this point and this point. Connect the dots. And this is 2x plus y equals 10. Now remember, if there isn't an equal sign, you do a dashed line, meaning that the points on the line are not part of the solution, but you need the boundary anyway. And this line, all right, if you plug in x equals 0, 2y equals 10, so the y-intercept is 5. And if you plug in y equals 0, x equals 10. So it goes through these 2 points. And this line was x plus 2y is 10. Okay, now what about the shading? Go back to the first one. X plus y is less than 10. All right, so that line, are you shading above or below it? Well, if you don't have it in mx plus b form, it's sort of hard to tell. So, and I don't, which you could do that to graph if you want. What I do is I pick a point not on the line, nice easy point, like say 0, 0. Plug it in, 0 plus 0, is that less than 10? Yeah, so I have to shade toward that point. That point is in the shade. So it's shading below this line. This line. Okay. Ben, what about the 2x plus y is greater than 10? 2x plus y is greater than 10, that's this line. Are we shading above or below that? Well, again, plug in 0, 0. Is 0, 0 in the solution set? 2 times 0 plus 0 is 0. Is that greater than 10? No, don't shade towards 0, 0. Shade away from 0, 0. So shade above that line. I'm not going to shade everything because it's a big mess. I'm just going to shade where they overlap, where the shades overlap. All right, the last line, 2x plus 2y, x plus 2y equals 10. That's this line. We're shading above or below that. Again, if you take a look at that line, and you pick a point off the line, like 0, 0, plug it in. 0 plus 2 times 0, is that greater than 10? No. So shade away from 0, 0, in other words, above. So don't we end up shading, over, all the shadings overlapping here? That's what we call the critical region. But what we're interested in are the corners of the critical region. This point, it's a triangle, right? So 3 points. I know this point, 0, 10. I know this point, 10, 0. I don't know this point. Let's figure it out. And that's what the rest of this chapter was all about, finding points of intersection, whether using a matrix, augmented matrix, inverse matrix, Kramer's rule, or a substitution method or elimination method, whatever. But that's these last two lines. So when do 2x plus y equal to 10 and x plus 2y equal to 10 intersect? Well, I'm thinking elimination. What if I multiply the bottom by -2? So the x's cancel when you combine. So 2x plus y is 10. I'm leaving that alone. And -2x minus 4y is -20. So let's combine like terms and you get -3y is -10 or y is 10/3. All right. How would you get x? Plug it back into one of the equations. Remember, there's a common point of intersection, so you can pick either equation and get the same value for x when you plug in y is 10/3. Well, sorry. Let's say 2x plus y is 10. So let's subtract 10/3 from both sides. Let's see. 10 over 1, when you come in the denominator, is 30 over 3. So 30/3 minus 10/3 is 20/3. 2x is 20/3. So divide by 2, and x is also 10/3. So this point is 10/3 for x, 10/3 for y. So now we have the critical points. What do? You plug them into the objective function and do what they say. I think this one they wanted to maximize it like it's a profit function. All right, so let's do that. Let's say here. All right, so z, whoops, what happened there? Why is it doing that? Oh, because it's still loading. Sorry. Okay, so z, the objective function, or profit function, is 5x plus 2y. And we're going to figure out what z is at all those corner points. So z at 10, 0, that gives you 50. Z at 0, 10, that gives you 20. And z at 10/3, 10/3. Assuming that you can make 10/3 of a widget. Maybe it's, I don't know, some kind of powdered drink or something, right? 10/3 of a gallon or 10/3 of a pound or I don't know, whatever it is. And usually these are integers, but whatever. So 5 times 10/3 is 50/3. 10 times 10/3 is 20/3. That's 70/3. Or divide by 3, 23 1/3. All right, so if you want to maximize your profit, which is your maximum? The 50, right? So I'll just circle the one that works. All right, so in this context, we're saying something. Now, usually this is part of a word problem. These examples are just the equations. You've got to come up with your own equations in a word problem. That's the only difference. And there's a context. So let's say, for example, you produce 10,000 cogs and 0,000 sprockets. Your profit is $50 million each month when you're running your factory, when you sell all these products, right? Something like that. Okay, so that's an example from class that'll get you going on your homework, which is page 800, multiples of 10. That was page 800, number 43. There you go. So I hope that was helpful, and I think we're done here. All right, have a nice day, you two. See you later. Bye-bye.